Today, we will learn how to make decisions in code. In the last video, we explored the Boolean data type, which plays a key role in decision-making. First, open CMD and navigate to your project's directory. Create a new project named Making Decision. Then move into the project folder. Finally, launch Visual Studio Code. Open Making Decision.dart file inside bin folder and delete generated code. As always, we need a main function, so Dart knows where to start executing our program. Making decisions in code is super simple. We use the if keyword, followed by a condition inside round brackets. The condition must evaluate to a Boolean, true or false. After that, we use curly braces to write the code that runs if the condition is true. Optionally, we can add an else statement, which contains code that runs if the condition is false. Let's start with an example. First, we will create a Boolean variable called isSubscribe. This variable will store true first. Next, we will use an if statement to check its value. If isSubscribed is true, we will print a message that user is awesome. When we run our program, it prints "You are awesome" in the console as expected. Now, if we change the isSubscribed variable to false and run the program again, nothing is printed because the condition was not met. But what if we want to show a different message instead? That's where the else clause comes in. The else block runs when the if condition is not met. Let's update our code to include an else statement. Now, since the isSubscribed variable is false, the only code that runs when we execute the program is the one inside the else block. Therefore, we see the message, "You're missing out," in the debug console. Now, let's look at a different example. We are not required to use a Boolean variable inside the if condition. Instead, we can write any expression that results in a Boolean, no matter how complex. For example, in the last video, we learned about comparison operators. Let's use one of them. Suppose we have a variable user age with a value of 23. We want to determine if the user can drive. To do this, we check if user age is greater than 18. If the condition is true, we print "You can drive." For now, let's assume that in every other case, the user can't drive. This is easy to handle with a simple else block. But we have a small problem. We can't use a single quote in the word can't, because Dart thinks the string ends there, and the rest is part of the code, causing an error. To fix this, we have two options. Either use double quotes around the string, or use a backslash before the single quote to tell Dart that it's part of the string. This backslash is called an escape character in programming. It helps us include special characters in a string that would otherwise be interpreted differently. Just like in a previous video where we used backslash to print a $sign, here it tells Dart that the single quote is part of the text, not the end of the string. Let's change the user age variable to 2 and make sure our program doesn't encourage toddlers to drive. We wouldn't want a 2-year-old behind the wheel, unless it's a toy car. Now, let's make our example a bit more complex. Suppose that if the user is older than 16, they can drive, but only with a parent. To handle this, instead of a simple else, we can add another condition by writing another if directly after else. This is called an else if statement, and it lets us check multiple conditions in order. Now, let's test if our program works correctly. Change the user age variable to 17 and see what happens. Great. But we still need to handle cases where the user is younger than 16. Right now, there is no message for them. To fix this, we will add our else block back so that if none of the previous conditions are met, the program prints an appropriate message. To recap, if user age is greater than 18, the program prints "You can drive." If it's greater than 16 but not 18, it prints "You can drive with your parent." Otherwise, it prints "You cannot drive." Our code has a small bug. If we set user age to 18 and run the program, it tells us that we need a parent to drive, But wait, I am 18. I should be able to drive on my own. The issue here is that when I wrote this example, I meant that users 18 or older can drive. However, there's a difference between what a programmer intends and what they actually tell the computer to do. Right now, our condition checks if user age is greater than 18, meaning 18 does not count as legal age. To fix this, we just need to change the greater than operator to greater than or equal to. This way, 18 is correctly included. Speaking of conditions, sometimes we need to check more than just two cases. That's where else-if statements come in. You can have as many else-if statements as you want, allowing you to check multiple conditions one after another. However, you can only have one else block, which acts as a final fallback when none of the previous conditions are met. And that wraps up our lesson on if and else. If-else statements are part of what we call control flow in programming. Control flow determines the order in which code runs based on conditions. Without it, our programs would always execute line by line without making decisions. But if-else isn't the only type of control flow. In the next lesson, we'll learn about another powerful control flow mechanism, loops. Loops help us run code multiple times without repeating ourselves. Stay tuned and see you in the next video.